Which of the following molecules or ions does not contain unpaired electrons? This question came in 2006 basically. So if we see, these are diatomic species, hence we can directly relate it to what? Molecular orbital theory. So first of all, for that we have to draw the molecular orbital diagram, right? Now we have two diagrams basically. One is for z less than or equal to 7. So for that we have the diagram of this sort basically. This is 1s, so it will give you this value, sigma 1s, sigma star 1s, right? One bonding and one anti-bonding. Now we will come to 2s basically, so it will give me this. Right, so this will be 2s, this will be sigma 2s, this will be sigma star 2s, right? Then we will come to 2p orbital, 2p basically, right? So for 2p we have so this is basically for 2p, this is pi 2px, this is pi 2py, this is sigma 2pz, right? This is pi star 2px, this is pi star 2py, this is sigma star 2pz, right? So this is the energy diagram for basically z less than 7, right? That means for species n2 plus and b2, this diagram will be valid. For z greater than 7, 2s and 1s remains the same. In the 2p there is a little change, right? What is the change basically? The anti-bonding remains the same, but the bonding, there is a difference. So this is basically the difference, right? What happens is this pi star 2p, pi 2px and pi 2py, they goes up and sigma 2pz comes down, right? So this is what basically happens. So for n2 plus, for N2, we are having, what is the atomic number of nitrogen? Nitrogen is having an atomic number of 7, right? So 7 plus 7 minus 1, N2 plus, right? So that means there will be 13 electrons. Is that right? Now for O2, we have, for 8 plus 8, which will be 16 electrons. For O2 2 minus, we are having 16 plus 2, which will be 18 electrons, right? Now for B2, we will be having 5 plus 5, which will be equal to 10 electrons, right? And it is having 13 electrons. Now definitely N2 plus will be having unpaired electrons, but is because it is having odd number of electrons. So we need not check this, we can directly cancel it out. Now we have to check between O2, O2 2 minus and B2, right? Now let us draw for B2. It is having 10 electrons. That means its configuration will be given by sigma 1s2, sigma star 1s2, right? Sigma 2s2, sigma star 2s2, right? How many electrons are done? 2, 2, 2, 2. That means 4, right? Now what will happen? One electron will go in this and one electron will go in this. That means pi 2px 1, pi 2py 1, right? So it is also having unpaired electrons. Now let us talk about O2, right? O2 will be having sigma 1s2, sigma star 1s2, same sigma 2s2, sigma star 2s2, right? After that, how many electrons are right now? How many electrons are filled? 8 electrons are filled. Now what will happen? This will start filling. So 2 electrons will come over here, right? So that means sigma 2pz2, right? 10 electrons are done. How many electrons are left? 6 electrons are left, right? So 6 electrons are left, 10 electrons are left. That means 1, 2, 3, 4, 5 and 6, right? So it will be pi 2p x2, pi 2p y2, and it will be pi star 2p x1 and pi star 2p y1, right? So it is also having unpaired electrons. But if I talk about O2 2 minus, right? For O2 2 minus, everything will be the same. This entire thing will be the same. Only over here 2 electrons are more. That means over here pairing will take place. That means it will be pi star 2p2 x pi star 2py2, right? So that means O2 2 minus does not have any unpaired electrons. That means option C is correct.